Why do we sleep if it makes us vulnerable?
It's really one of the most profound paradoxes in biology. Think about it. For a third of our lives, we just stop. We cease foraging, we stop seeking mates, and we completely lose our environmental vigilance. We are entirely exposed.
Every night, the body becomes quieter, less alert, and slower to respond. That seems risky, but evolution may have preserved sleep because not sleeping carries deeper survival costs. Learning, memory, attention, immune function, physical health, energy regulation, and daily functioning. To really understand why nature insists on this trade-off, we have to look past the stillness of the sleeping form.
Consider the exact nature of this paradox. Externally, you're looking at profound vulnerability, stillness, sensory disconnection, completely lowered physical defenses. Now, out in a dark forest full of predators, this looks like a fatal flaw. But internally, beneath that quiet surface, the body is performing vital, incredibly high-stakes activities. It's repairing cells, it's archiving memories, and it's engaging in this active immune crosstalk. So sleep isn't some passive shutdown. It's a highly active, non-negotiable state of survival.
Section 1. The microscopic toll. Repairing the quiet systems.
You say wakefulness itself acts as a relentless battle, and that battle takes a heavy toll on our biological fortress. Just the mere act of being awake leads to neuronal DNA damage, it leads to the accumulation of metabolic waste in the brain, and progressive immune suppression. The waking state is, by its very nature, destructive to our internal systems. We literally have to retreat from the external world just to repair the structural integrity of our own cells.
And we see this across the entire animal kingdom. Studies on organisms as primitive as jellyfish and as specialized as Mexican cavefish reveal this universal truth. Wakefulness inevitably increases DNA breaks in individual neurons. This is damage driven simply by metabolic activity and cellular stress. What the research clearly shows is that this foundational genomic hardware can only be adequately repaired during the low-activity, offline state of sleep. It's an ancient requirement deeply woven into the very fabric of complex life.
This inward focus becomes especially critical when we look at our internal defenses. Deep sleep essentially serves as a vital crucible for the immune system. Naive T cells, the ones critical for recognizing new threats, they physically redistribute to the lymph nodes during deep sleep. So while we're safely at rest, the body is actively cataloging the dangers of the day. At the exact same time, we see a peak in systemic cytokine production, along with the nocturnal release of growth hormone which drives tissue repair. The body simply cannot mount this level of restorative defense if it's simultaneously scanning the horizon for predators.
Section 2. The price of plasticity. The informational cost of the waking state.
To really grasp this burden, we have to look at the synaptic homeostasis hypothesis, or SHY. This concept defines sleep as a necessary offline period used to proportionally scale down and renormalize our saturated neural connections. Imagine your brain as a set of dimly lit, overflowing archive drawers. During the day, every new experience, every face you see, every sound you hear, it all strengthens the synaptic connections in your brain. But that takes up immense space and energy. SHY proposes that sleep is the time when the brain goes through those overflowing drawers, carefully pruning away the noise and keeping only the essential signals.
So the waking brain is in this state of constant acquisition. It's strengthening connections, it's consuming massive amounts of energy, and eventually it saturates its capacity to learn. It just becomes too noisy. The sleeping brain, conversely, engages in down-selection. It restores cellular homeostasis by proportionally weakening synapses, extracting the true signal from the day's noise. Without this nocturnal renormalization, our neural networks would become entirely overwhelmed. Our ability to learn would just cease.
This entire mechanism is perfectly synthesized by researchers Giulio Tononi and Chiara Cirelli. They state simply, sleep is the price the brain pays for plasticity. To remain adaptable, to remain capable of learning from our environment during the day, we absolutely must surrender our consciousness to the dark each night.
Section 3. Mitigating evolutionary threat. Adapting to the dark forest.
Now, animals across all ecosystems employ some highly specific behavioral strategies to honor this biological need to rest, while also minimizing the risk of predation. And they do this in a few ways. They alter where they sleep to reduce environmental exposure, they adjust the depth or the duration of their sleep state based on the immediate danger, and perhaps most fascinatingly, they employ asymmetric vigilance.
Unihemispheric slow-wave sleep is a profound adaptation observed in birds and aquatic mammals, like dolphins. It's a state where one cerebral hemisphere exhibits deep sleep while the other remains awake. Imagine that, half of the brain resting deeply, while the other half stands guard at an empty watchtower. For a migrating bird, this means keeping one eye open to monitor for threats. For a dolphin, it allows them to maintain the muscle tone necessary to swim and surface for air, all while satisfying that non-negotiable biological demand for sleep.
Humans, well, we rely on a different strategy. It's called the sentinel hypothesis. This suggests that variations in our own sleep timing, what we casually call larks and owls, actually evolved as a communal defense mechanism. By naturally staggering the times we fall asleep and wake up, a group ensures that someone is always awake, or at least in a light, easily arousable stage of sleep. So our natural variations in chronotypes are very likely the remnants of an ancient night watch that protected the tribe. It allowed individuals to lower their guard simply because the collective group remained vigilant.
Section 4. The ultimate survival trade-off: synthesis and preservation.
So what happens if an organism actually attempts to evade this restorative trade-off? Well, if we try to remain perpetually vigilant, the biological collapse is systematic, and it's devastating. Avoiding sleep results in rapid cognitive deterioration, attention lapses, and decision-making fails. This is quickly followed by systemic metabolic failure, including the disruption of hunger hormones and the onset of metabolic syndrome. The immune system is severely compromised, and at the deepest, most fundamental level, we see accelerated cellular aging and shortened telomeres. The shield shatters entirely.
Sleep is not a flaw in the armor. It is a system-level resilience mechanism. It is the vital, quiet time when the armor itself is forged. The temporary lowering of our guard is the exact mechanism that guarantees our systemic preservation. By retreating from the external world, we ensure that our biology remains viable, adaptable, and ready to face the demands of the next dawn.
Which leaves us with this final thought. If sleep is the necessary forge of our survival, what is the ultimate cost of refusing to lay down our arms?